Welcome dear students, and let us discuss about a division algorithm given by Euclid. So that is today's topic. Let us discuss the division algorithm given by Euclid's and also Euclid's division lemma. It is also called as Euclid's division lemma. So because division algorithm and Euclid's division lemma will be almost the same, and with the help of Euclid's division lemma, we find HCF of two numbers, any two numbers, positive numbers. And what is the use of Euclid's division lemma? We can find HCF of any numbers by using methods. Else we have factorization method is there. In your lower classes you have learnt. But what is the use of Euclid's division lemma? Means Euclid's division lemma can be used to find the HCF of larger numbers. If two larger numbers are also given, we can find the HCF of the two larger numbers by using Euclid's division lemma. First of all, let us see what is division algorithm. You know that here A is equals to BQ plus R. Here A is dividend. What is A? Dividend. And B is divisor. Q for quotient and R for remainder. And for any two positive integers A and B are any two positive integers where A is bigger number is nothing but dividend and B is smaller number divisor, then we can find Q and R. We can find quotient and remainder with the help of this dividend and divisor. As you know, when you divide the dividend by divisor table, we get some quotient, and afterwards the result may be something. At last you can find you may get remainder like this. But in Euclid's division lemma, you have to follow the procedure till you get remainder 0. Till you get remainder 0. For example, let us take one example for Euclid's division lemma. We have 40 and 30. Yes. And here 40, 30. How do we find the HCF of 40 and 30? Let us discuss. Here what is the larger number? 40 is the larger number. Here A is equals to larger number 40 and B is smaller number 30. Let us apply this formula. Euclid's division lemma. What is it? 40. Now we have to divide by 30 table. Isn't it? 30 table how many times? 30 ones are 30 because 32 is a 60 becomes more than 40. 30 ones are 30 and how much is left out of 40? 10 is left, which is called remainder. Here remainder or is not equal to 0. Is it equal to 0? No. So therefore we continue this method. We continue division lemma for the remaining two numbers. What are the remaining two numbers? What would be the remaining two numbers? The remainder and given number. Yes. Now let us take. What is the divisor? Now divisor becomes dividend. Divisor becomes dividend and the remainder becomes divisor. Now you check by 10 table. 10 table how many times? 10 3s are 30 means no remainder. Remainder is 0. Here R is equals to 0. Till you get remainder 0, you have to go on simplify the problem by using Euclid's division lemma. This method is called Euclid's division lemma. Is most important question you can expect in your internal examinations and also in public examinations, that is final examination. So this is called Euclid's division lemma. Here always remainder must be equal to 0. 0 less than or equal to remainder. But you know that remainder is always lesser than B. What is B? Divisor. Remainder, that is remainder or is always less than B divisor. You know that because remainder is always smaller than B, that is divisor. If it is greater, then we go for next table, as you know, division algorithm. Yes, so this is called Euclid's division lemma, and with the help of this method, let us start our first exercise questions and first bit. And once again, let me explain. Here a is equal to bq plus r. In Euclid's division lemma, any two integers, positive integers a and b, we can find HCF of that any two positive integers a and b using Euclid's division lemma. But how do we solve? We have to divide the bigger number by smaller number, then we get remainder, some remainder. Again, the divisor should be divided by the remainder, again you get some remainder. Till you get remainder 0, you have to go on the procedure. The procedure is called Euclid's division lemma. And let us continue the first exercise problem. Yes, here the very first question of the first exercise, first chapter, real numbers. We have two numbers, 900 and 270, bigger numbers. We can find HCF of this bigger number by using Euclid's division lemma. And what should we take first of all? Here the formula is, you know that, A is equal to BQ plus R, where 0 is less than or equal to remainder and less than B. Yes. And now here, what is A? A is bigger number, as you know, and B is smaller number, 270. And let us follow this method, division method. 900 should be divided by 270. 270 table. You can do in rough column also, no problem. 900 in 270 table. 27 table, 27 3 is 810. That's it. And 90 is remainder. Let us apply. Divisor B 270. How many times? 3 times. That is quotient. Plus remainder. What you have got? 90 is a remainder. This is A is equals to BQ plus R. But what is R? Is it less than, is it equal to 0? No. R is equals to 90 is not equal to 0. So let us continue the process. Now what do they become? Now what is A? What would be A? This 270 becomes A, divided, and the remainder becomes divisor. Now 90 table 270 directly, 93 is a 270, that is remainder 0, and here A is equals to BQ plus R. Here what is R? R is equal to 0. So therefore HCF of 900 and 270 is, when did you get 0? We have got remainder 0 by dividing 90. When you divide 90, the final divisor, the final step, what would be the divisor? 90 is the divisor. So therefore the HCF of 900 and 270 is 90. So this is the process. A very simple questions. This type of questions 100% surely you will get in your examination. It's very clear. Don't get confused, my dear students. Just to keep in the mind the formula A is equal to BQ plus R, but the remainder, final remainder must be equal to 0. If you don't get remainder 0, you continue the process till you get remainder 0. And let us continue one more question in the same bit. Yeah, one more question. Two numbers 196 and 38,220. One is smaller number, one is very bigger number. So be alert, be careful while doing the division. And here A is equals to BQ plus R, and where 0 less than or equal to R less than B. And here what is A? A is bigger number 38,220, and according to division lemma, and B is the smaller number 196. Let us see in the rough column. 196, we have to divide this number with 186. Yes, 196 twos are directly we get 382. Remainder 0. Not remainder, directly. And next, take it down 2. Yes, not possible. Again 0. Because when you are going to take two numbers, you must take a 0 here. Now it becomes 20. Now 196 table, 20 not possible. You can say 196 zeros are. Now you divide this number. 196 zeros are 0. Now the remainder is 20. Just to take, this is A and this is B and this is Q, this is R. Let us substitute here. A, that is 38,220 is equals to BQ. B is 196 into quotient 200 plus remainder is 20. This is A is equals to BQ plus R. Here R is 20 is not equals to 0. So let us continue the process. Now this becomes A and now this becomes remainder, this becomes B. Now 20 table 196, you divide 196 by 20 table, 20 directly 9s are 180 and 16 is the remainder. So therefore 9s are and the remainder is 16. A is equals to BQ plus R, but R is equals to 16 is not equal to 0. Let us continue the process. And now this becomes 20 becomes A and the remainder becomes B. 16 table 20. How many times? 16 1s are 16. 4 is left. And here A is equal to BQ plus R, but R is equals to 4 is not equal to 0. Let's apply or let's continue. Let's say continue division lemma. Let us continue division lemma. You have to write for every step. You have to write this statement surely. Okay. Now what is that? 16 becomes A and remainder 4 becomes B. 4 table 4 4s are 16 and finally we have got remainder 0. Here R is equal to 0. So therefore division lemma is satisfied with these numbers and therefore the HCF of 196 and 38,220 is, when did you get? 4. So this is 4. So just like this you can complete the remaining problems. That's all. Before going to start the second question of first exercise, let us review our previous knowledge. Generally, when two numbers are given 16 and 20, how do we find? We used to find the different method, factorization method. How do we find HCF? Using factorization method, prime factors method. 16 can be written as, find the prime factors of 16. 2 2s are 4, 2s are 8, 2s are 16. And 20, what are the prime factors of 20? 2 2s are 4, 5s are 20. Now here, what are the HCF? HCF becomes highest common factor. What do you mean by HCF? Highest common factor. This is also called as GCF or GCD. Greatest common factor, greatest common divisor, highest common factor. All the three give us same meaning. Yes. How do we find? By using prime factorization method. In your 8th class and 7th class you used to learn this. It's very simple. Round up the common factors. One common factor, that is 2, and one more common factor, because the number should be in both the rows. 2 rows, it should be in 2 rows. Yes. and remaining not there. No common, no 2, no one more 2 is repeated, no one more 2 is repeated, 5 is not repeated. So finally the HCF is 2 2s are 4. So in this method we can find the HCF of smaller numbers. But what we have discussed just now, that is called Euclid's division lemma, that is very helpful to find the HCF of highest larger numbers. And once again, let us see what would be the LCM of 1620. Different, using prime factorization method. Same 16. What are the prime factors? Just now we have taken. And 20. What are the prime factors? These are the prime factors. Yes. Now LCM is nothing but, here also first of all take out the common factors. 1 2 and one more 2, and remaining how many numbers are left in the problem, left in the 2 columns, all the numbers you cover. You take it down, all the numbers what are left here. 2 is left, 2 is left, and down 5 is left. Now finally multiply them. 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 5s are 18. So this is the LCM. LCM and HCF can be found, can be solved by using prime factorization method, which you have learnt in your lower classes. But now in 10th standard we use Euclid's division lemma to find the HCF of larger numbers. Let us continue the second question. And first bit we have completed 2 problems, and one more, the third question you can try, and let us continue the second problem in the next class.